Sorry for
Sorry.
Okay, so I can keep going, I guess. The first public dataset I'm going to mention is Google Mobility dataset. Basically, for each of the dataset, I will try to gather a few of the features so that you can make a comparison of the different aspects that you can capture with different mobility datasets. So one of the first things that is important to consider is the sample. For Google Mobility dataset, basically the sample that was used was people who have location history turned on. So by default, the location history is turned off on your phone where you're using Google. So this sample is very particular because this is really people who have chosen to share the location. So basically they accept to give their GPS coordinates during the day. So it's a very rich data set on one side because you can really see how people move around. But at the same time, it might be a very peculiar sample because this is only people who have chosen explicitly to share their location. So I'm specifying this point because this is always the point that has to be in consideration when you look at this mobility data set, that you might always, you will always have some kind of bias that you need somehow to take in consideration when you're going to discuss your result. The metric that they share, so of course they didn't share something at the individual level because everything has to be GDPR compliant and they are not supposed to share an individual data set. So they have shared aggregated values, and basically what they shared was the reduction in time spent in different categories of places expressed in percentage. So I will describe what are these categories. And so most of the time in this data set, so like in the Google Mobility data set, they had to choose a baseline. So when was the normal time, how was the mobility when the time was pre-COVID. So in that case, they basically gathered several weeks that were from January to February 2020, and they could compute what was the normal level of moving of people. And then they could compute what was the variation of this mobility. Then another point to look at is, of course, the resolution, the temporal resolution of the dataset you might have access to. Here it's quite rich dataset because you have this at the daily level. So here also in terms of privacy, the aggregation, the temporal aggregation is also one point that is important. And then, as I was saying, the data set is aggregated, and here the spatial resolution is either at the country level or the region level. So this is basically the main features of the data set. So as I said, the Google Mobility reports capture the mobility in different categories of places. So basically they check what were the percentage of variation in mobility in retail and recreation. Here I put an example for one country. I can't remember which one I've chosen at that time. You can see this during the last period. So you can see that there is not such a big change compared to the baseline. So they did this, as I said, for retail and recreation, for grocery and pharmacy, for parks, transit station, workplaces, and residential. And you have this at the level of the countries and the region. And so this is a very interesting data set as we are looking at different categories of places. And if you are thinking about policies that you can put in place, this might be very relevant. So for instance, all the effort that was done to ask for people to work remotely clearly had an impact on the spread of disease. So it's very interesting to have access to these different categories. And also the same thing for example, for the recreation places, what was the impact of the different containment measure on this quantity is something that is also very relevant if then you want to look at the spread of COVID. Of course, for each of these datasets, very nice data visualization were done. So here I'm going to show for each of these datasets a few examples, but you can find a lot of them. So here it was developed by the Center for Disease Control, and basically they just used directly the mobility reports from Google, and they plot the different trends. And if you go on this dashboard, you will also have access to other quantities that are quantities related directly to the spread of COVID. So for instance, the number of cases or the number of deaths. And so this helps as it makes easier the confrontation between the reduction or any kind of changes in mobility and the spread of COVID. So of course, what you observe in the different studies is that you have a lag when you look at the changes in mobility and the spread of COVID. So this is one of the dashboards that was developed that used this dataset, but there are many studies using this Google mobility reports. Another type of data source that is public that I would like to describe is the Apple mobility data. So this is a very different data set in terms of sample. First of all, because this is in terms of bias here, you have also something very important is the fact that you are going to look at users who have iOS and not Android users. So of course you might have a bias, for instance, on the income of these people, and the population might not be representative. So the data set is still interesting by itself, but again, it's important to take into account this kind of bias when you're going to look at this data set. And then the type of data set is also different from the one gathered by Google, because this is basically the sample is basically the people who use Apple Maps. So basically it's going to look at a different metric that is the variation in the number of requests that is done on Apple Maps. So basically the trips that are done by people and not making any requests on what is the itinerary, what is the best itinerary to do it, are not taken into consideration. Here again, a baseline was defined. So this baseline was not exactly the same as the one from Google, but still it was more or less the same period because it was taken in January. The temporal resolution is the same as the Google dataset, as it is given daily. And the spatial resolution is even better for some countries than Google, because not only you have country and sub-region, but you also have access to this dataset at the level of cities, of course, just for the major city. So let's look a bit at this dataset. So here, these are time series that are directly provided by Apple. So on the left side, what you see is a time series over the different phases of the pandemic, of the number of requests that was done on Apple Maps. So again, it's a comparison with the baseline. So it's a variation given in percentage with respect to this baseline I was mentioning that was taken in January. And you can here look at different countries at the same time, and you see that countries in Europe were more or less aligned in terms of variation. And the point that is interesting, very interesting with this data set is that you can basically separate by type of transportation. So you can see here on the right, I put for one country chosen at random. I looked at the time series obtained on the variation of the number of requests with respect to the baseline for public transportation, car, and by foot. Sorry, it's in French because I could not get it in English for some reason, but I guess you can understand it easily. So you have access to this time safe for the different kind of transportation people were using. So this is very interesting. For instance, if we want to look at what was the impact of COVID on the way people are moving. So you might have seen that in some cities, there was, for instance, a very strong effort to add new cyclable path, and people started to use a bit more the bike. So this is something you're not going to see directly in this data set, but you can see, for instance, that at some point the public transportation was used less because probably people were concerned about the spread of COVID while taking the public transportation. So on one side, there is the negative side of this data set, that is that you might have a strong bias on the type of users, but you have it on any type of data set, let's say. But on the other side, they give you access to a very nice aspect of change of behavior, like on how people adapted their behavior during the different phases of the pandemic. And for instance, it would be nice to see if on the long-term basis, people still use less public transportation because they just took new habits. So this data set basically enable you to capture a very different aspect of change of behavior linked to the COVID, and not only during the pandemic itself, but also on a long-term basis. Also, there were very nice visualization done. So it is not, so I'm showing this visualization, so it's not about how nice it is, but it's more about how convenient it is, because on this page, so the link that I put here, basically we are giving also the code. So here what you can see is for different cities, they look at the variation in driving during the different months of the pandemic, and you see very different behavior for the different cities, because you see that for some cities, like for Paris, basically during the whole pandemic, it seems that there was mainly a decrease in driving. While for New York City, for instance, at some point during the pandemic, probably during the lift of some of the restriction, there was an increase in the use of cars. And this might be linked to the point I was mentioning before, is that people, instead of using public transportation, decided to use their own car when they were able to move. So if you want to see, there's the code on this page to do this plot, to load the dataset, not only the Apple dataset, but they show you also to load the Google dataset. But basically for Google, it's very easy because these are just CSV files. And then how from these files, how to build this time series. Another very interesting data source is the one provided by the Facebook Data for Good program. So here also the first question to ask is the kind of sample you have. So of course, this is going to be only about people who are using Facebook on a mobile phone, and they also have to opt for location history and the background location collection. So here again, you will this dataset has its own bias to be taken into consideration. So you will see that for different countries, this might have very different impact, because there are some countries where the market share of Facebook is very high, while in other countries might be lower. And then there's also the question of opting for the location history. That is not something that everyone is going to do while using Facebook. Another type of bias I would like to mention, but that you can see for most of the data set, is also again the type of system you are using. So it's not also it's not only a bias in terms of who use what kind of people use iOS and Android, but it's also on the way the GPS coordinates are captured. because the frequency with which it is shared might be very different based on the device. So sometimes, even if you would have access to data set with a very high temporal resolution, you should take into consideration the fact that each device might have a very different frequency to capture the location. Anyway, in all of these data sets that I'm mentioning, we are going to talk about aggregated data sets, so it's not so much of a concern. In terms of metric, here we are looking also at movement changes, but they do it in very different way with respect to Google. So what they did basically is that they had these tiles that are called Bing tiles, that are more or less tiles that are 600 meters by 600 meters. And then they look at which individual, or more exactly, how many individuals they could see in each of these tiles. And before this, they were somehow attributing home to each of these users, so based on where they were spending most of the time at night. And after doing this, they could basically count for any tiles of a given region, how many moves were done by the people living there. And they could compare this quantity to a baseline quantity. So how many tiles each people from a given region was visiting with respect, I mean, this on the current period with respect to what was happening in February. So here the baseline was taken in February, while for Apple we just seen that it was in January. So this also might have an impact on what you are looking at. So this is also one point to take into consideration. So this thing that we are still looking at a baseline that is 2020. This is something that that is important to think about, because also now the kind of reason we have might be very different, even if we reach a time where the COVID is not spreading so much. It can happen that the mobility is not even going back to what was before. So this question of the baseline is also, I would say, a critical point, but of course in that case you don't have any control on this. And not only for the fact that COVID had an impact on the behavior of people, also probably on the long term, but also due to seasonal effects. So of course what you're doing in February might be very different from what you're going to do during the summer. So the use of this baseline is also something that can be questionable. But as I said, for this data set, it's not that you have any choice. So in terms of temporal resolution, this is the same as for the previous data set. You basically have a daily resolution. For the spatial resolution, you have what is called NUTS3 for European countries. That would be basically the equivalent of provinces in the different countries. So provinces and region. And then we have the GADM2 for other countries. So it would be, I think, like for like the counties for US. Okay, so also in that case, they have made nice visualization. Here I just put some of the documentation that is accessible on the Facebook website where we share the dataset, where they describe very well what are the different fields you have. So there's the timestamp. So as I said, it's daily information, so it would be given as a day. There's the country, and then there are these polygons that we're mentioning that that were basically originally in the data set that is not shared directly by Facebook. You have the information about these tiles I was mentioning, these 600 meters by 600 meters. But here, on the aggregated data set they are sharing, this would be given at the level of the region. So what you really care about is just the region name. And then they give a quantity that is called all-day Bing tiles. So basically, this is what I was mentioning before. This is the variation in the number of tiles people are visiting in a given day. and this change is relative to the baseline. Then another quantity that is very interesting is and that they call the old duration, is the proportion of users that are staying put within a single location. So not only they are looking at how many tiles each user is going to visit in a day, but they are also looking at this user who are staying in the same tile. So of course you can imagine that for the spread of COVID, this is a very interesting quantity to look at, because it can also be a good proxy on what's happening in terms of the spread of the disease. And then you have two other fields that are baseline name and baseline type. As I told you before, the definition of the baseline is very important, because this might impact quite a lot your data set. And so it tells you basically when the baseline was calculated with the pre-COVID reference, and how also this baseline was computed. Because one aspect to take into consideration also is if they consider the different days of the week in the same way or not. So in some of these data sets, they put together, for instance, all the Mondays together, and they really took this into account while calculating the baseline. While maybe in another data set, they are putting all the day of the week together, but still making the differences between what would be the normal behavior during weekend and during week. So here again, it's not so much of your concern if you are taking directly this data set, because they have already done the job. But in case you're lucky enough to get your own data set with raw values, this question might be important. So how to consider the different days for generating your baseline. Again, very nice data visualization were developed. So here, these are visualization directly done by Facebook, so that you can find on the research Facebook page. On the left, what you see is the relative mobility change. So it's still the same quantity I was mentioning, that is the variation in the number of tiles that are visited by the people living in different counties. And on the right, you have, it was originally an animation, but yeah, I just share a picture. But if you go on their website, you will have a very nice visualization of what's happening day by day on this quantity that is called stay put, that I just explained. That is basically the number of people who are staying in a tile that is of a size of 600 meters by 600 meters. And then you can see what is the variation of this quantity during the different phases of the pandemic. And so it's very interesting, because you can look at the heterogeneity, the spatial heterogeneity of this quantity during the different phases. And so here we are using directly the public data set I was mentioning you. So you can see already that you can do very nice things just using this aggregated data set. Another visualization done by Facebook is that one, that is part of a more broader project that looks at the the population at risk. So here, COVID is of course seen as a crisis. As there have been other crises, COVID is seen as one, and they care about looking at population that are at risk. So what is the most vulnerable population with respect to COVID? So here is just what I'm showing here is just a map showing the change of mobility at the country level, and you can have an overview of what's happening for the different countries on a specific day of the year. You can change the day of the year if you wish, but there are other quantities you can look at that are more related to COVID itself. And putting all this together, you can look really at what is the population that is the more at risk. So if you look at the link I'm sharing on this slide, you can have access to a very nice tutorial that show how to use QGIS, so this spatial analysis tool, in order to look at the population that is at risk here with respect to COVID. Then the final data set I want to mention, and the one we have been using here to develop one of our study, is the Cubic data set. So Cubic is a location intelligence company. And during the pandemic, they shared some of the data at an aggregated level, and also at a more refined level with some of the research institute. And we were lucky enough to have access to some of this data set, but we are anyway sharing some of the data set at an aggregated level. So here again, the question is about the sample. So in terms of the sample, it can be pretty nice, because basically this is a sample that concerns users that are using different kind of application. The only thing is that we don't know, of course, which application they are, but these are different applications put together. And these are users who have explicitly opted in to provide access to their location data. Of course, it's anonymous, like for the other dataset, and through a GDPR compliant framework. So this is the case for all the dataset I'm mentioning, of course. But again, you might have some bias, because not everyone is happy to share the location. And basically sharing the location, you have access to the GPS coordinates. The metric they gave access to were different kind of metrics. They have basically what they call the mobility index. You have some details about how they computed in their web page, but basically this captures the main trends in the mobility, and you can have different ways of using their dataset, and we will see one together afterwards on how to compute some kind of mobility variation. But this mobility index is taking into consideration the distance, because having access to the coordinates, the GPS position, or people were at different time of the day, they can basically compute what are the typical distances traveled by people. And then they also have another kind of metric that is a bit similar to the Google variation when they are looking at people in staying at residential places. And that is also a bit similar to the stay put given by Facebook. So they are looking at the people staying at home. This data set in terms of temporal resolution and spatial resolution. Before aggregation, so something that is not public, the dataset they have is an anonymous hashed user ID. Then we have the timestamp and the latitude and longitude that is associated to this timestamp. They have some accuracy, so spatial accuracy, and then the type of device. So the type of device, as I say, was important because you might have an impact on the type of system you have, on the frequency on which the coordinates are taken. Anyway, this is before aggregation. What we are more interested in here is the after aggregation, because this is also what is provided to everyone. So this public data set, and especially the cases where they shared a lot was the US, where they basically gave daily information. So like for the overall data set, and they gave it at the looked at Italy, and we were basically aggregating the data set at the province level, and we've been sharing this, but I will describe this a bit more afterwards. Okay, they also done their own data visualization. Sorry, so that is available on the Cubic website, and they have computed this mobility index. So in that case, you can also see the variation. So we have to define as well a baseline. And on the map, they give you on a given day. So you have the possibility to choose the day. It was 19th of July. So you can see that there's no strong changes in the way people were moving. So they are giving this value with respect to the normal behavior, but they're also giving a variation of mobility index they define that can take different values. So it's usually better to look at the variation more than at the quantity itself, because it's hard to say what 4.17 means, or at least I don't see it. So you can have access to this data set to have access to general trends about mobility during different days, and for the different counties in the US. And you can also look at this visualization. In terms of visualization, they also looked at quantity, that is a relocation index. So the pandemic has, of course, changed behavior, not only on a daily basis, but also on a more long-term basis, as I was saying before, as people decided to relocate and take, for instance, a new live. So this let's say that the fact that people were encouraged to work remotely has changed a bit some of our habits, and this can be seen in where the people have been relocating. So they are also sharing visualization about this phenomenon. If you want to look at, it is the link. Then there are external people who have been using this data. So here at Oxford, they've done both visualization of the different time series of this variation of mobility. So they might have computed this mobility index in a different way. There are several of these dashboards using cubic dataset that you can find, and they will have their own way to compute what is the mobility change, because of course mobility can be captured in different ways, and I will show afterwards with our study what could be an example of mobility index, let's say. And not only they have this time series, but they have also a map showing the variation of this quantity. They also could look at the flow. So this is, of course, a very interesting quantity when you look at the spread, to look at the flow between the different regions of a country. And then they also could know about some visits to some POI. So this is a point that is particularly relevant for the case of the US, where they had quite a huge sample, and you could do something a bit similar to what Google was doing with different categories of places. So that is interesting in the case of the policies you might want to put in place. So knowing in which kind of places there are more movements, let's say, might be important in order to inform new policies. Okay, these were for this dataset, and as I said afterwards, I'm going to show more specifically the case of the cubic dataset. I just want to share with you just a few other resources that are interesting according to me if you want to look with mobility data. So one thing that I'm showing here is the COVID-19 mobility data network. That is basically a network of infectious disease epidemiologists at university around the world, and that are working with different companies to look at mobility. So this website has different resources that you might be interested in. So we have different type of technical resources. So if you want to get access to some code, also some example of mobility data metrics, because as I mentioned to you, there are different ways to capture the mobility. They have over different points, like the future direction that could be taken by a researcher in order to better capture what is happening in terms of mobility and consequently in terms of the spread of the disease. So I think it's a very nice resource. Here is, for instance, what they've done together with Facebook. So, I mean, the network of epidemiologists and Facebook Data for Good program. So here you can see what is born from this nice collaboration of this kind of dashboard, a comparison between the different countries, looking at the different movement trends. Another resource that I would like to share is this this website that is doing some kind of mobile location data inventory. So these are all data sets you can have access to. And this is nice because basically for a given data set, so for instance, for the Facebook data set, they show for which country it's available. So if you want to make a comparison between different countries, you might directly see what is the data set that is most appropriate. Then the fact that the same data is accessible for different countries does not guarantee you will be able to make a good comparison because of different aspects like I was mentioning before. So the fact that there is, if you are using Facebook, a different market share in the different countries makes that you're going to compare very different samples, but still you can have a proxy of what is happening. So even if you're using the same data source, it's not guaranteed that you can safely make a comparison. You of course need to control for some confounding variables. Okay, so now that I described some of the main data sources that are public about mobility, I want to share with you a more specific case that is something we've done here in ISI, and where we've basically we've been looking at mobility in Italia during the pandemic, right from the beginning, because we started February last year. And so we've been looking at different things, but the study I want to show here is on how mobility changes changed with the different phases. And we focused, so in this particular study, we focused on what was the pre-lockdown behavior. So that was basically before the enforcement of the national lockdown. So it would be more to look at what would be the spontaneous behavior of people regarding mobility during COVID. So seeing on the news that there were like some cases. So in Lodi here, that was one of the places where somehow where everything started. So if people would get scared, like hearing this news, maybe they decided spontaneously to move less. So we wanted to look at what happened during pre-lockdown, then what happened during the first lockdown. So where there were, of course, very strong mobility restrictions that were at that time quite uniform in the country, but still could have heterogeneous impact on the different regions of the country. And then doing what was called the phase 2, that was basically when some of the restrictions were lifted. So we wanted to use this cubic data set in order to see what were the different changes and what could impact these different mobility changes. So in this cubic data set, basically we considered 40,000 users. So the fact is that we could have used less users, but our concern was to have users that were present during the whole the whole period. So meaning during these 3 phases that are pre-lockdown, lockdown, and phase 2, so that we could have a safe comparison. So as I said, these are users that were active every week during these 18 weeks of the study. These would still represent quite a lot of location because it was 300 million of location. So here I'm talking not about the aggregated dataset. I will show you how we built the aggregated dataset, but we were lucky enough to have access to some kind of raw data set where we could see something at a higher resolution, higher temporal and spatial resolution. And then we had an accuracy about the spatial location that was pretty good because it was between 50 and 100 meters. Okay, so the thing is that we, of course, didn't want to work directly with relocation dataset for privacy reasons, and also because in any case, aggregated data is a good way to capture the main trends, as what you have seen in some of the paper I shared at the very beginning. These are a very good proxy to see what's happening. We made this panel selection I was mentioning above. That is important. That there was this condition that users should be present during the whole time period. We've done this time sampling we have this time sampling of 5 minutes. So basically, even though we could have a higher temporal resolution, we decided to aggregate it at the 5 minutes level because of what I explained before. The fact is that different devices might capture the location, might collect the location at very different frequencies. We made a spatial aggregation at the level of the provinces. So this for different reasons. One, of course, is because we wanted to look at aggregated level. It's something that is logical to look at the province because some of the decision might be taken at the province level, and also the data related to the pandemic, like the number of deaths and number of cases, were given at the province level. So once we wanted to relate the mobility quantities to this quantity about the epidemic, it was more convenient. And we basically looked at 3 different quantities in terms of mobility. So as I explained, mobility can be measured in very different ways. And I think it's very important in terms of the spread of the disease that different aspects of mobilities are going to generate, are going to have different impact on the spread. So we looked at the flow, so basically a origin destination matrix. We're looking at the trips of people and what was the origin of this trip and then the destination. So basically to estimate what was, for instance, the flow between different provinces. So of course you might directly imagine that this had an impact on the spread of the disease. So if you think at the seed of the disease and then you look at the province of the seed and where the people outcoming of this province, of course, you might understand this might have an impact on the outcoming province. Another quantity that I'll describe afterwards, that is the radius of gyration. That is basically something that gives you an idea about what is the typical distance people are traveling. And then we also looked at what we call the proximity network. So that was basically something like looking at what was the collocation of individuals. Given that we know, we could know more or less where we are at a given time, we could look at something that is a proxy for the probability of collocation of people. And this is also something that is very important for when you are looking at the spread of disease, as you can imagine. Just to somehow make a summary of what I just say on how we have monitored the mobility, we looked at different quantities. So one was to look at the short-range mobility, and we looked at this typical distance travel. I'm going to explain how we computed this. We also looked at long-range mobility, so it's about the flow of people between the different regions. And then the spatial proximity, that is capturing when people are more likely to find themselves in more or less in the same location. So you can understand that these 3 different metrics are all capturing some aspect of mobility, but a very different aspect that might have a very different impact on the spread of a disease. Everything that we've done at the very beginning was shared on a website. If you're interested to see it, here I'm sharing a link. So we started, from the very beginning to share some of the mobility index we had, just in case you're interested to see what we were doing at the very beginning. Then now let's start really with what was the art of the the study and how we proceed. We had to proceed. So of course, the first thing we had to do, and that you usually have to do when you are doing such a study, is look at the representativeness of your datasets. So for some of the datasets I shared with you might be more complicated because they're already shared at very aggregated level, and you don't know exactly which sample you have. So how your sample is distributing across the different regions. But if you had access to something a bit finer in terms of spatial resolution, in terms of the number of users that were assigned to each of these how can I say, part of the spatial resolution, you should look at the representativeness. So in our case, we basically look at the representativeness at the province level. So we looked on one side at what was the distribution of the users we got from our datasets, from this cubic dataset in the different provinces. So we could assign a home to these different users, again, looking at where, in which region they were, or in which province, in that case, we were passing most of the time during the night. And then on the other side, we collected our data sources. So in that case, we gathered census data about the distribution of the population. So during this study, of course, not only the mobility data set is important, but all other kind of dataset, public dataset that you can gather to validate your data or to explain your data is very important. So I will show some of them during the talk, and one of them, of course, is the census data. And this point is quite critical because you want to know how representative your data set. In that case, it was pretty good. You see quite a high correlation between our sample of users and the census data. Of course, here it's capturing the representativeness only in terms of the spatial distribution of people. You might be concerned about the other type of distribution, like the income distribution, but in that case, of course, we did not have access to this information. And here you can see if there was a bias based on the different regions, like North, Center, and South. But basically, we were pretty fine in terms of representativeness. And this study was done both at the province level and at the neighborhood level. We also looked at the neighborhood level. So we looked at these mobility changes both at the province level and at the city level. So we have chosen cities for which we had a sample that was good enough in terms of number of users. So we got Turin, Milan, and Roma. And we again used the census dataset to confront it to our sample of users, and we were pretty happy because we could see a very good correlation. So this is our starting point. We are fine because at least in terms of the spatial distribution, we have something that is pretty representative. Okay, and as I said, we wanted to capture different aspects of mobility, and one of them was the short-range mobility. So we computed this quantity that is used a lot if you use, for instance, mobile phone dataset, and that is called the radius of gyration. So here, as I said, in the raw dataset, you got access to the different GPAs location of people. So you could basically look at what was the center of mass for each of the user. That is basically the weighted average of all the position. And then you could compute this quantity, this radius of gyration, confronting the different location with respect to this center of mass. So, and you divide this by the total number of location, and then you take the square root of this quantity. And basically, this quantity is giving you an idea of what is the typical distance people are traveling on a given period of time. Okay, so this quantity could be computed, for instance, for each day or for each week. So this is for what concerns short-range mobility. We also looked, as I said, spatial proximity. So the way we did this is that we assumed that a good proxy of collocation was if people were observed in a radius of 50 meters in a given interval of hour, and a network using this. So that was 50 meters of the probability of having two people collocated. Okay, and then we wanted to look at this different quantity. So before I mentioned also a third quantity that was the flow, but for this presentation I decided not to put it. If you're interested in this, you can go, of course you can ask me something about this, but you can also go on the website we did and that I mentioned before, or also look at the publication for which I'm going to share the link. So I'm going to look here essentially at radius of gyration and the degree. That is basically a proxy for the number of people each user might encounter during a given period of time. So the first thing we did is that to look at the behavior at the national level. So for Italy, what was happening. So as for the other data set like Facebook, Google, and Apple, we had to define a baseline. So here we took basically a few weeks before, I think 22nd of February, where or 20, I don't remember exactly, where it was the moment when we had the first case declared in Italy, and we could compute what was the average radius of gyration. So this quantity that you have originally for each user. So here you aggregate at the country level this quantity by doing the average. We did this during the pre-COVID period. I think we took something like 4 weeks before this day in February. And then we could compute for each following week what was the variation with respect to this value. So we did this both for the degree, that is a proxy for collocation, and then the radius of gyration. So the general behavior for these two quantities here, as you can see, is more or less the same, but they capture very different aspects of mobility. And you can already see here what's happening during pre-lockdown, lockdown, and phase 2. So there was a sharp decline immediately after the first official report of a cluster of COVID cases. And so that was probably due to some self-induced behavioral changes. So this is why the pre-lockdown was interesting to study, as I said before. And then there was kind of a stable time where you see the weekly pattern. And then when some of the restrictions were lifted, you could see that the mobility was starting to increase slightly, even though it was not going back to normal yet. And you could capture this both looking at the degree and at the radius of gyration. So this is interesting because this gives us gave us what was happening at the national level. But of course, you can have very heterogeneous behavior. So within the different regions, you might have very different behavior, even though the restriction would be the same. And we were interested to understand if this was happening, first of all, and then if this was happening, what could be the reason that explain why there were these differences. And the reason why I wanted to do this is also thinking about new policies you could think of. So, if we could identify that some features were explaining why we had these changes in mobility in a region and another type of change in mobility in another region, if you could this, then you could better adapt the type of policies you could put in place. We, as I say, we looked at the province level. So we looked at the relative change of the average radius of duration during these 3 phases I was mentioning. So the pre-lockdown, the first, and then the phase 2. So the pre-lockdown, you see that the behavior is very heterogeneous. Some provinces, and of course the provinces where it started, had right where a strong increase in the typical distance people were traveling. So you can see here with this red and blue colors that there were very heterogeneous behavior in all Italy. And then you also had some effect about holidays, but okay, let's say it's a side effect here. And then during the lockdown, thing apparently tend to be a bit more uniform, even though it's not exactly the case. And then phase, we see that there was a bit of an increase in the mobility, but again, is not uniform across the provinces. One thing I want to mention here is that if you get some of the provinces that are white, it's just because we had to get rid of some of the data set because we had not enough user to get something that was statistically something you also, that is something that you also have to take into consideration when you have a data set. If you don't have a sample that is big enough to have something that is statistically significant. Okay, so we see globally with this map that there might be some heterogeneous behavior of the provinces. So we wanted to try to explain what was these differences. So we gathered over datasets. So as I said, not only the datasets are an important source, but other type of dataset given often by statistical institute important. And we basically wanted to look at aspects that are the demography, territory, economy, and epidemic variables, and see how we could somehow link these features of the provinces to the different changes we observe in mobility. So for the demography, we basically collected what was the old age index, the percentage of females, the number of people with higher education. Then we also consider the population density of the different provinces, because of course might have an impact on quantities such as the degree, because of course the probability of being collocated in a place that is poorly populated is lower. The number of residential buildings. In terms of economy, we looked at, we collected the average income of each province, the rate of unemployment, number of commuters, the percentage of people working in different sectors like agriculture, industry, and services. And finally, we of course also consider epidemic variables like the attack rate, that is basically linked to the percentage of people that get infected. Then the different type of social distancing orders that were put in places, because at the very beginning there could be some slight differences between the provinces in terms of social distancing orders that were put in place. Okay, and then what we did is try to a model to explain the different variations. So what you see here in the top are the variation of the radius of duration with the baseline during the 3 phases. So we took 1 week during pre-lockdown, 1 week during lockdown, and 1 phase 2. And you see how these variations change with time. So with the pre-lockdown, you see, for instance, that the reduction was stronger with time. So if you go towards the end of the week, it was getting stronger. Same thing for lockdown, because there is some kind of a transient to arrive to some stable state where the reduction remains more or less the same. And the phase, and then 1 week in the phase 2. Okay, and we build a model with all the features I mentioned before. So as just a multi-regression model using these features in order to predict what would be the different variation in mobility in the different provinces. And below what you see, so something that captures the intensity, so the importance of each, let's say the importance of each of these features to explain the reduction. So for instance, you see unemployment seem to be strongly linked to the variation in the mobility, so more exactly in the radius of gyration, with a positive association. So the provinces where there were more unemployment were also the provinces where there was a stronger reduction in mobility. And one thing we observe, so yeah, I'm not going to detail, of course, each the impact of or not the impact, but the link between each of feature and variation in mobility. But the real thing we observe is that the distribution of the workforces explain most of the variation, because basically we see that during pre-lockdown and lockdown, industry was associated with a stronger reduction in mobility, while in phase 2, it was the case of services. So the provinces where there were more people working in services, so like people working in a restaurant, for instance, where the provinces where there was a stronger reduction. So as you can imagine, this is something that is important to take into consideration when you want to do new mobility restriction. So the labor force is what's going to shape what's going to happen in the different provinces. So here I was showing the 3 weeks, but we looked over the whole timelines and did exactly the same thing. So with a daily basis, we computed the average reduction of mobility in terms of radius of gyration for the different provinces, and we could look at the time series. And then we made this one multi-variate regression for each of the day and looked at the importance of each of the quantity. So the reason why we did this for each of the day is not that we're thinking that each day was different, but is that we could capture like, let's say, like long-term, capture trends more than capturing what was happening day by day. So if we see features that are repeating from one day to another, it means that there is a strong association between the reduction and this quantity. So for instance, population density, of course, as we might expect, was an important aspect in the mobility reduction. So what we can see if we look at all these phases put together is that the provinces that had the higher unemployment were also associated with a larger reduction. Provinces that were characterized by larger agricultural workforce were instead characterized by a relatively smaller reduction of the radius of gyration. And this might be explained by the fact that agriculture still need to keep going during this period. And finally, we also see as a general trend that older and more educated population were usually associated with larger mobility reduction. So this is one first thing we could capture by looking at this reduction of duration. Then, as I said, we also looked at a proxy for collocation. That was this quantity that is called the degree. And we looked at this variation. So the pipeline is exactly the same as before. We looked at one representative week for each of the different phases, and we can look at how the variation is going. And for each day, we had this regression model where the covariates are the same as before. And the main thing we observed in that case, so in this other mobility index, let's say, is that agriculture is negatively associated to the reduction, while it's the country for income. So for this agriculture part, this is something we also for the radius of gyration. Instead, we didn't see this for income. We did this also for the whole period, so not only for these 3 weeks. And then again, we confirmed that larger reduction in proximity were also associated with higher income in every phase of the outbreak. Of course, there was the importance of the attack rate. So on the number of cases there were in the different provinces. So provinces where the number of cases were higher were seen to have a higher reduction in proximity. And well, one other thing that is important for the very beginning of the pandemic, it was that large gathering ban was also associated to larger reduction. Okay, so this was for the study at the province level. I want to conclude just with the study at the city level. So as I said, we were lucky enough to have access to data with very high spatial resolution. So we could look also at the heterogeneity at the city level, so at the neighborhood level. So here what you are seeing is the spatial patterns of variation in collocation in the different metropolitan areas. So as I say, we studied Torino, Milano, and Roma. What you can see for pre-lockdown is that Torino and Milan experienced a very early decline, even during this phase that can be understood given where the spreading was seen for the very beginning. And other thing that we could notice is that we observed a stronger reduction in the most central district. So the most central district were seen with like biggest change in the collocation probability somehow. We did the same kind of study to explain this heterogeneity. So how can we explain that we have a really different behavior within the same city, comparing the different neighborhoods? So the quantity we could gather were very different with respect to the province level. So we looked at the percentage of people with high education in the different neighbors, the percentage of female with the different neighbors, and then the percentage of residential building, and again the population density in the different neighborhoods. And we built again a regression model that was supposed to explain the variation of the degree in the different neighborhoods. The main conclusion we had, and that stands for the three phases, is that the neighborhoods where there was higher proportion of people with higher education were positively associated to reduction. We did also the same thing for the whole time series of this quantity at the city, at the neighborhood level, sorry. So putting all the neighborhoods together, the neighborhoods of Torino, Roma, and Milan. And we looked at the link between the four covariates I was mentioning, so high education, female, residential buildings, and population density. And one striking point we've seen is that the neighborhoods where there was a higher proportion of women appear to be negatively associated with the reduction. That might seem counterintuitive with some of the studies that were done, that were basically surveys that were seeing who were the people who were more compliant when there were containment measures, mobility containment measures, because women were seen to be more compliant. So it was a bit counterintuitive to find this, but this compliance could be also explained in other terms, like people more compliant to wear masks, or things like this, and still women could be constrained to move for different reasons. So this was one of the striking results we got. So for these specific studies, basically one of the phenomena we observed is interesting was the fact that the desertification of city center in large urban area was still there also during the phase. So when the first restriction was started to be left. Another point that is critical if you think about new policy, new restriction you could make, is the fact that the labor market was mainly explaining the geographical variation we are seeing in mobility reduction. And finally, one of our important point is that demographic factors like old age index are positively associated to the reduction. If you want to know more about these studies, we had 2 papers that I'm sharing here, and of course I'm happy to answer any question about this. About the data availability, as I mentioned, we aggregated the data set and we shared them at the province level on a daily basis. And you can see here, for instance, a very nice visualization that the New York Times did with this data set. So just to convince you again that even with public data sets, you can get a very good insight on what's happening. I would like to thank my collaborators for this particular work, and then thank you all for listening to me, and I'd be happy to take any question.
Thank you very much, Laetitia. So I guess we are opening the floor for questions. Anyone also in the chat?
I'm not so sure I can see the chat.
The chat is on the side, I guess.
Yeah, maybe because I'm sharing the screen. Okay, maybe I can stop sharing. Okay, I can see it now. But I don't see any question on the chat.
Yeah, so let me start off with the point that you made on passive. I think it's very interesting. I was thinking about
on the sorry.
A point that you made in the very beginning, which I think is very interesting, but I would like to ask you more about it. So it's true that all this data set that we have access to have a baseline that is now quite old, so more than 1 hour and 1 year and a half. So what do you think is going to happen with that? So they're going to change it? So we should change it now? So because now we are speaking about COVID since quite a bit. So and also in terms of other data, for example, thinking about models that have other data set of mobility in the mix, like think about GLIM, with all the transportation data, commuting. So how do you think we could or we should homogenize the data in order to, to capture this new reality that we are all gonna live in the next, I don't know, 1 year and a half or whatever we're gonna be, it's gonna be?
It's a very tricky question. So, I mean, for now, we didn't see any stable period. It's not that we reached some kind of equilibrium. So I think every day is a surprise on, I mean, what we're going to see. So defining a new baseline now, I think it's very, very hard. But one thing that could be done for sure is like, at least considering. So this is independently of what's happening with the COVID, the fact that we are considering February as a baseline for what's happening in July, I think that intrinsically this is not that this is wrong, but this is something that is already going to introduce some bias. So at least considering baseline that consider seasonal changes. So first, maybe going back to what was happening at the same time during summer, not last year, of course, because we are already in that.
And now we are getting some questions from the participant. I don't know if you see I can read it to you. So Francesco is asking, have you also started to observe something about coupling networks between locations in Italy? For example, that could have influenced the outbreak order. I think is referring to commuting across regions and how the maybe variation in mobility as well, induced by the disease, might have shaped the disease itself. So I guess this is what Francesco is asking. Francesco, feel free to jump in.
Yeah, so I mean, I guess you're referring to the impact of the flow between different regions, and also the, I mean, impact of seeding or multiple seeding. So for this particular study, we didn't look at this aspect. So the fact is that, yeah, you can group together provinces or cities or neighborhood of the city that tends to have the same kind of strand. But then, so it depends. I mean, this coupling, if you're, yeah, I see that you are meaning in terms of the outbreak. So in our case, we really purely looked at the changes in mobility. We didn't want to make a direct connection with the spread of the disease. So so to answer your question, we did not in this particular study worked on this aspect, because we were just interested at looking at the changes in mobility. Then it's another big important part of the work to look at what's the direct link between the outbreak and these changes in mobility. So of course you can see direct link, like how reduction is impacting, for instance, the reproduction number or things like this. But I think to me, so I would not feel confident doing this just because I'm not an expert in this field. So basically, yeah, in this study, we didn't look at this aspect.
Any other questions? Guys, feel free to ask questions. So I have a general point that I want to ask you. So what do you think is going on? So what do you think is going to happen with this type of research in the next, let's say next year or so? So now, I mean, now we have a lot of study about mobility changes. So we have all the things that you mentioned, many other studies as well that that kind of somehow cover in different countries, different socio-demographic regions, all the things that we. So I'm wondering, so what do you think this research going? So I'm curious to know your thoughts about it. So I think it's gonna be over. So now it's gonna be like all news, or maybe you see.
Yeah. I think it's not going to be over, but I think I'm at least for what I'm thinking, for what I would like to do is to understand, I mean, to go deeper in this aspect of mobility, because we always speak about mobility, but then as I shown in the presentation, different aspects of mobility can be captured. And the fact is that to me, it's not clear if you really want to go to a refined level, what is the best aspect of mobility that is capturing the dynamic of the disease? So I think the next step would be probably to go a bit deeper in the understanding of what is really the good metric that is capturing mobility for the spread of the disease. Because of course, if you look at how far people are going, or how many people they are likely to encounter, this is very two different things, and they are both somehow seen as change in mobility. But I think that there is still the lack of the link between the different metrics, so how a different metrics can capture well a different aspect of mobility, and then how it can be linked to the spread of the disease. I think that there is still something missing there.
Yeah, I completely agree. Also, how to translate. I mean, we're speaking about with Michele many times. So how to bring also that beyond the understanding of the data and but also into modeling. So modeling the epidemics. How you do couple of that. So which type of information you need in order to put that in the model. So I think that's, yeah, I agree. It's gonna be part of the future research there. So any other questions?
I don't specifically have a question, but I do have a comment. Is that so I'm a behavioral scientist, I'm a social psychologist, and the way we usually do research is like to ask people about their self-report behaviors or self-report feelings and attitudes, etc. I noticed, for example, the MIT combining Facebook survey, this is the type of surveys like we are relatively familiar with, but it seems to me that there are not many combinations of self-report data with all these passive phone data or mobility data, combining them. Do you know some of them like done in a large scale? For example, we do have some data like in a very small scale, but I don't have like this type of like massive data plus a lot of participant self-report.
Yeah, that's an interesting point. But the survey usually were more like, as you say, about general behavior, like wearing mask or, I mean, just deciding to get out of your place or not. So the direct comparison, I guess, is not that easy, and I'm not aware of like some work trying to do this, because I guess it's a very complicated task. Like also I'm thinking about mobility. What would you like to compare exactly? But I think it's indeed an important point you made.
Yeah, me too. I'm not sure. I mean, I know about some one app that was very popular with more than 500,000 users. They ask about symptoms and what how they if they change mobility and this like. But I don't think that by design they are tracking actual mobility. So
yeah, Facebook somehow is doing both, because they are doing the surveys and they are also capturing mobility. Yeah. But then I haven't seen they were like trying to put everything together, but I might have missed.
I guess also for privacy reason, I think is put together might be a bit harder to justify anonymity. I guess to save anonymity. I guess. A good point. Good point. Any other questions or comments as we are phasing out the day? Okay, if not, I will really like to thank Laetitia again for this very interesting talk, for her time late in this very hot day, I guess, also in Turin. And thank you everyone for staying so late. So thank you, Laetitia, again. So for everybody else, let me stop recording.